What are we starting with this week?
Patreon,
No,
Spotify update.
Yes.
Really?
We are. We are starting with the Spotify update. So,
Because it's been a while since the last one.
I decided to check it. And actually, what's really interesting is I checked it on Saturday, and then I checked it today, which is 2 days after Saturday.
Wow.
And it's gone up by 150 people.
Wow.
Yeah, look at that. It's
That
pretty
is
cool.
a lot in 2 days.
It's a lot in 2 days, isn't it? It's a lot. So it's sitting on 18,225
We
right now.
did it!
We're
We
getting
did it.
so close to
We did it.
20k.
Let's get to 20k. I think maybe, can we push 20k for the next one?
Well, because somebody'd have 20k on YouTube and Spotify.
Oh my God, that'd be so
That would
cool.
be amazing.
If you're listening on YouTube, you need to head to Spotify right now. You need to go there and you need to hit follow on Spotify. Follow us on Spotify.
If you're listening to this right now, get the link and just share it with a friend with no context whatsoever. Just text them the episode and then just wait for their response.
If they ask questions, you're not allowed to respond.
And if
just,
you've just-
just say, just watch it.
If you just received this in a text with no context, welcome.
We
Follow
hope
us
you
on
enjoy.
Spotify.
Follow us. Exactly.
And tell your friend that you love them. You know, life is short.
They care about you. They sent you this. Wow. That's not an indicator that they care about you, actually.
And before we properly start the episode, I want to ask everyone a question. Everyone that's watching, everyone that's listening, head over to YouTube, get in the comments, and tell us, what is your favorite shape?
Oh.
5-dimensional cube. What's it called again?
That's what I was
Tesseract.
That's a fourth dimensional cube.
Yeah.
4th-dimensional cube. If you can edit that, Jen, that'd be great.
No, I'm not. I'm going to leave that all in.
Right. Why don't we start the show?
A rhombus. Thank you.
I didn't ask.
Dodecahedron.
Let's start the show. Hello and welcome to SCI GUYS, the show where we talk about the crazy, weird, and wonderful stories from the science world. I'm Corey, and as always, I'm joined by my co-host, Jamp and Luke Cutfer.
That is correct.
Hi, welcome.
This week, we're talking about Buckminster Fuller.
Yay, Buckyballs.
Oh, you know about him?
I know about Buckyballs. And he also invented graphene?
No.
No.
No,
No.
we
So I
talked about
don't.
graphene before, and I've not heard of this.
Wait, he had that thing where there's like all those, like, it's just like a circle with all the lines connecting all the little dots around the circle?
Yeah.
Yeah.
Cool. Great. Thank you for spoiling it. Literally 5 seconds.
Hell yeah.
Yeah.
I still know nothing, and I didn't get anything from that, so you can teach me.
You didn't get anything from Luke's expert explanation of
No, it was a big word vomit, I think.
No, it's going to make a lot of sense in a little bit. So Buckminster Fuller, do you guys know who Buckminster Fuller is at all? Do you know anything about him other
No.
than what Luke just said?
And
Other
he
than his
discovered
name.
Buckminster Fullerene.
No.
No?
He didn't. He didn't.
Who did?
Well,
If not Buckminster Fuller.
Is that a real thing?
Is Buckminster Fullerene a thing?
we'll get to it in a minute. We'll get to it in a hot minute.
Okay.
Okay.
Oh, God, I'm so lost.
Open the window. It is hot.
Buckminster Fuller, his full name is Richard Buckminster Fuller. So his first name is Richard, but he goes by Buckminster or Bucky. Everyone called him Bucky. Feels a little
How
familiar
is
for me.
Buckminster short for Richard?
That's his
His
first
middle-
name.
Richard is his first
Richard.
name. Buckminster is his middle name.
Oh, his middle name.
And
Okay,
Bucky
fine.
is short
I thought
for
you meant his real name is Richard, but he goes by Buckminster. Is it like a shortened version? 'Cause I've not heard that. I've heard Dick. Dick's short for Richard. Buckminster, I've not heard.
You've heard Dick.
Yeah, it's
What does it sound like?
tiny scream.
Oh, okay.
Tiny scream.
Richard Buckminster Fuller, known better by his middle name Buckminster, shortened to Bucky. He was born July 12th, 1895 in Milton, Massachusetts, in the United States. Died 1st July 1983 in LA, California, which means that his life spanned pretty much the entire 20th century.
That's pretty good.
It's pretty good.
Like the Queen.
Yeah, I suppose, yeah. Actually, yeah. When was she born?
Like the 20s.
Was she really?
I think so.
She's coming up
she's
to 100
old.
then.
Yeah, she is.
Wow.
She's getting there. She's very old.
Will she send a letter to herself? I know that's a joke everyone makes, but I do want to know.
No, because she's not. There's something weird where she's not technically a citizen of the United Kingdom, right?
Question answered.
Yeah, there
Let's
you go.
move on.
Something weird like that. So, as I said, his life was almost the entire 20th century, and so he obviously saw a lot of things change throughout his lifetime. You know, I mean, cars were invented just the late 1800s,
Oh, yeah.
and so he saw, like, you know, from when he was young, the start of those to where we are now. Everything kind of just happened in that 100 years, and he saw most of it. So he was in the Navy during World War I. He came back and he married a woman named Anne Hewlett, who was the daughter of James Monroe Hewlett, who was an architect and a muralist. And then he went into business with James Hewlett, started a sort of construction company essentially, and he was building houses for people over the years. And then in 1927, the company had sort of financial difficulties. Any guess as to why that is?
The war?
In 1927.
Oh, because of
Oh,
the economic crash.
Yeah.
Was that the Great Depression? Is that what that was called?
Pretty sure it was called that, wasn't it?
Yeah.
I thought it was the same thing.
Don't know history.
I
It's the
thought
Sci
maybe
Guy.
everyone was just really sad.
It's the Sci Guy. It's not the history boys.
Exactly. I always failed history. Too much remembering.
That's every subject.
Yeah.
No, there's not, like for maths, there's not as much remembering because it's just like,
Did you get
One-
Fs in most of your tests?
did I get, no.
You sure you can remember?
No.
So in the
That's
20,
That's a good point, actually.
yeah. So in 1927, the company faced sort of financial difficulties, and him being a minority shareholder was forced out. So he was in Chicago with no money, basically with nothing. He didn't have anything to do. He had no money. He was stuck in Chicago. He didn't know what he was going to be doing. And so he decided to use the rest of his life to work on non-profit research for design patterns that could maximize the social uses of the world's energy resources and basically help the world using as much energy, basically using as little energy as possible to get as much out of it, right? So he's a pretty cool guy. And he invented a lot of stuff. He discovered a lot of things, and he created quite a lot of things. And he said that he wasn't really an inventor or an architect, despite the fact that he designed sort of, I guess, buildings or structures and invented a number of things. He didn't like thinking of himself as an inventor or an architect because he said that all of the things that he created were either accidental or just steps along the way to making the world sort of a better place to solve the world's problems. And so his kind of philosophy was, like I said, to get the most out of as little as possible and to really sort of improve the world in ways that are pretty cool. They're still kind of radical today, right? Like he wasn't the kind of person that you'd expect to be around that time, a raging capitalist who thinks, yes, the best way to get through life is to take as much as possible and win. He was like, we could all live like on the island of Haiti. Haiti. We could all live on Haiti, and we could live all comfortably in like Florida or whatever, in that sort of surface area of the planet. So there's no reason that we shouldn't be able to live comfortably like across the world by using energy efficiently and using resources efficiently and sharing so that everyone kind of gets enough to survive and then some.
And it turned out he was completely wrong.
Yeah, so wrong.
Oh.
As economists will tell you,
Shame.
the economy just won't allow it. And the economy,
It's impossible.
the economy controls all,
Yeah.
you see. Luke, you study economics, that's right?
That is correct. I
Okay.
study economics.
And
I can confirm that poverty is entirely necessary.
And if I'm, please do
Not.
correct me if I'm wrong. The economy is a big dragon monster that lives in a cave somewhere and eats money. Correct?
More or less.
That's what I was led to believe.
Yeah.
Mm.
Because we need to feed the economy.
Need to
That's
feed
how
the
it
economy.
works.
Yeah.
Okay, good.
And also, you got to ask questions like, where's the money going to come from?
From the economy?
No.
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 Okay. Good.
Mm.
Glad to understand this.
Yeah.
Fantastic. Let's move on.
Fantastic.
Think you will understand now?
Yeah, well, yeah, I think.
Capitalism is
I
a
might go for
reflection
my
of human
degree,
nature? Yeah?
Mhm.
We're good?
Yeah.
Mhm.
Yeah.
Mhm.
Cool. Wow. I think
Trickle down economics
I
works
feel like
really
I've
well.
got my master's in economics now.
You
It all
bet-
trickles down from the
Yeah.
economy.
Well, don't worry. If you wait long enough, a master's degree will trickle down to you.
Oh, sick.
But you got to wait for someone real rich to get
Got to
it
wait
first.
for the dragon thing to drop it.
Yeah.
The economy.
Yeah.
Flies across.
Sorry, yeah, the economy. Sorry.
Flies across the planet sometimes, dropping down.
That's what it
master-
means. Trickle down, right? It just drops some money here and there, trickles down.
Yeah.
So he basically wanted to solve problems throughout his life, and throughout his career, he traveled around the world. He gave lectures. He wasn't sort of specifically a scientist. So I'm really kind of stretching the definition of Sci Guys here to include him. I just think that it is interesting, the stuff that he spoke about, the stuff that he created, stuff that he did, and it does kind of involve science. Luckily, science is a broad topic, so we can include basically whatever we want. And he wasn't a scientist in that he didn't necessarily do studies in the way that we expect most scientists to do. He was more, I guess, an inventor. He invented things. He thought about ways to solve problems, and he came up with some pretty cool ways to do it. You guys haven't heard of him at all,
No.
Yeah, I have.
really? You have?
Yeah.
Other? Wait,
Well, I
in,
knew
in what
about-
context?
I heard about him in context of Buckyballs and Buckminster Fuller.
Okay.
Yeah.
Then I think if those are the only things you know about him, I don't think you know as much about him as you might think,
Why do you think I'm here?
because you're paid to be here.
No, I'm not. We break even at best. Head over to our Patreon, patreon.com/SCI GUYS.
Yeah, so as I said, he traveled around the world, sort of trying to solve problems and really sort of revolutionize how we went about things. And in doing so, he created a number of things. So there's the term Dymaxion. Have you heard of that before?
No.
Dymaxion? No. So it comes from the words dynamic maximum intention. Basically, he wanted to maximize energy use from sort of as little as possible. And the term was originally conceived by an advertiser who was speaking to Buckminster Fuller about his house, and he called his house the 4D house. We'll get into that in a bit, maybe. And he listened to him sort of talking and going on about it, and he heard the words dynamic maximum intention coming up over and over and over and over. So he thought of the term Dymaxion to kind of put them all together into a sort of portmanteau. Yeah, there we go. You passed the test. Well done.
Thank you.
Yeah. And Fuller took the word and applied it to everything. It's like kind of if you see the word Dymaxion, it means it's probably something from Fuller. So there was the Dymaxion house, which was created in 1927. So in 1927, he basically invented this kind of house that can be assembled in a factory, delivered like through the air, and has its own utilities in it. And he called it the Dymaxion house. Essentially, the idea was you could build this house in a factory and drop it to a place where you need someone to live, and boom, they could live there.
These are becoming really big out in Los Angeles at the moment. Elon Musk, I think, lives in one at the moment. He's
Really?
had it's like a prefabricated house where it's like made in a factory and transported on the back of a truck and then just installed in the location where you want it. They can be stacked on top of each other. Apparently he lives in like a $50,000 house on the SpaceX headquarters. And it's just basically like a shipping container that has a bed, sofa, fairly basic living conditions, but perfectly like everything you would need to exist, just not luxurious in any way.
I've seen videos of this. I've also seen videos of ones where it's like parts of houses and then you just slot them together
Oh, that's cool.
at the place where you want to build it.
That's really.
Yeah.
I feel like I'm struggling to remember something from history when I was younger. This was I think this might have been during World War II. It might have either been in Germany or in the UK. There were these houses that were basically made to be very easy to build. They were like not quite prefab, but basically the flat back IKEA furniture of houses, which is really cool. I just feel like the way that we build houses, the way that we build houses now is maybe not the most efficient use of resources, is it?
No, well, those, I mean, it may be Germany you're talking about because prefab houses are quite big in Germany. I think a lot of the industry is taking off in Germany. I mean, they're not necessarily particularly efficient in the way we build them, no. Because they don't use any of the sort of production line processes or kind of economies of scale that you get from a factory floor.
And as well, what's really interesting to me is, I mean, I've been seeing a lot of houses recently from looking at sort of, do you know tiny houses? Tiny house?
Oh, yeah.
So tiny houses like those kind of tiny house shows are on a lot in my house, not through my own choice. And so I picked up.
Subtle.
I want them gone.
I don't dislike them. I just don't. You got to be a bit pretentious to want to live in a tiny little house, you know? And then take people around. Look, this tiny house. There's enough space for you to have a bigger house. You just want to have a little house. Anyway, they just want a little.
I've seen house tours on YouTube for tiny houses, and they go surprisingly long.
Yeah.
How big the houses are.
Well, exactly. What bothers me about tiny houses is when people have kids and they're like, "Look, we've made the kid. They share a room and they've got like this tiny hidden away spot just for them. And just get a normal house for your child, please. Give them this. Like you could make this decision for yourself, but don't like give your child a shared room and then you have like the rest of the shipping container to yourself. You know?
Don't impose this lifestyle.
Yeah, exactly. No, so like seeing that, you see a lot of houses that are almost sort of that can be almost off grid. in that they're pretty much near enough self-sustaining.
Mhm.
So you've got like solar panels that like to take energy for like to create energy, and you've got like the sort of the plumbing. There's the three, the three tiers of water, where you've got the sort of like clean water, like brown water and black water.
No.
So you've got clean water, that's drinking water that comes through the tap, and then once that's used, that can be filtered. That can be put into places like the toilet, and I think sort of other systems where you don't need the water to be specifically clean. And then once the stuff that comes from the toilet, and I think the shower, maybe like that sort of stuff, that is black water, and then that's then filtered and cleaned. And
I see.
yeah, it's pretty cool. But this is so he had this was back in the 1920s, and obviously he had this idea for this house that could be just airdropped, people could live in it, and it kind of, you see how it follows his philosophy. And then in 1933 and 34, he sort of launched these things called Dymaxion cars, which I can get an image up for you in a sec.
Please.
He designed it in 1928, and he manufactured it in 1933, and it was basically that was the first prototype. It was a 3-wheeled car. They had front-wheel drive, rear steering, and it had an engine in the middle, but it had 2 wheels at the front and 1 wheel at the back. And I've seen someone drive it, and he said it's really sluggish and it's difficult to turn. It's difficult to drive. I mean, obviously this was a replica of a prototype that he drove, but it's a really interesting looking car. It's supposed to be sort of streamlined.
Oh, it looks like a spaceship with wheels.
I think it looks like a cucumber.
So this is what the Dymaxion car looks like. You can see it's sort of supposed to be streamlined, right? And there's supposed to be room for 12 passengers. He said that it could drive 120 miles an hour, but on the top is made of sort of canvas. So whether it could actually reach 120 miles an hour, particularly in the 20s, is sort of remains to be seen. But apparently it could cross open fields like a Jeep. It could make 180-degree turns like in its own length, because of this rear wheel is the one that steers. So it's kind of like, it's almost like a rudder in a ship. Do you know what I mean? So like instead of, and the way that it drives is that you kind of have to return to center in a way to stop it from turning in a certain direction. If you think, if you just sort of try and visualize how something would drive with rear wheel steering, because most cars that we use now have front wheel steering, but the power comes from the front wheels rather than the rear wheels, right? Whereas most cars now, most of our cars have rear wheel drive, correct, or 4-wheel drive, right? Yeah.
If you're listening on the podcast, Google this: Dymaxion.
There will be links to Dymaxion cars in the sort of description anyway, so you can have a look at those.
Can you turn at speed in one of these? Because it looks like you'd have to almost stop to make a turning.
You don't need to stop, but turning feels rickety.
I'm quite scared to imagine turning in that.
Yeah, it is not exactly what you'd want out of a car necessarily. But to be fair, this was a prototype. It never went to sort of manufacture. Right? There are obviously going to be problems with them, but the idea is pretty sound. Like as a car, it's probably not the most efficient. It's probably not the best way to do it, but you can see how his idea, a car that can fit 12 people in it, it's as streamlined as can be. Sort of using the front wheel drive, 1 wheel on the rear and steering. Apparently, it could get 28 miles to the gallon of gasoline, and like I said, it had a canvas top. And in 1943, he was requested to develop a new version that was supposed to be powered by 3 separate air-cooled engines, each coupled to its own wheel. So it'd basically be 3-wheel drive with 3 different engines. But it never actually got commercially produced or anything like that. Like none of them were commercially produced. There were basically 3 prototypes made of these cars. And that was it. And there are replicas. You can see replicas and ones that are made to be exactly like it, but they never were mass produced in any way.
It strikes me as potentially dangerous that you have separate engines driving separate wheels, because if like part of the benefit of one engine driving both wheels is that you don't get one wheel going faster than the other wheel.
Yeah.
You have I think it's a drivetrain turns both the wheels. And so, but if you're in that and one wheel starts turning faster than the other because one engine fires quicker, then you're going to turn.
You're going to turn without meaning so. Yeah.
Also, it's occurred to me that if you are somebody who drives, then this is, because it's rear wheel turning, it's essentially the same type of turning as you'd get whilst reversing. Now, obviously, you might have a steering wheel that is actually helpful and not left turns right and right turns left. But essentially, you get the same sort of handling as reversing.
Yeah. Apparently, the interior is made to be like a boat. It's like being on a ship.
Yes, it looks like it.
And it's quite spacious on the inside. You know, I mean, it's a big thing. But apparently, yeah, the turning is awkward and odd, and it doesn't quite feel right.
Because if you imagine it's pointing the other way, it's essentially a car reversing.
Yeah, I mean, I think the steering wheel turns the correct.
Of course, yeah. But in terms of like, it's essentially just a car that's doing the opposite, as in like the back wheels are driving and the rear wheel is turning. Well, that's the opposite of a car
that we've got now. Yeah. But it's only got the 3 wheels, and it's an odd contraption. It's pretty cool. I don't dislike it, but as a sort of car that actually works, I'm just like, maybe not.
I reckon you could roll it quite easily by turning too fast.
I think that's why the 2 wheels are at the front, because that's harder to roll.
Oh, really?
If you've seen the Mr. Bean sketch with a 3-wheel car, it's very entertaining and shows the problems with like a Reliant Robin, or the Top Gear segment about the Reliant Robin where they flip the car. They are apparently harder to flip than those things suggest, but hey, if that's the public perception, no one's going to buy a 3-wheel car, regardless of how hard it is to flip.
Yeah.
You saw people driving this at speed, and it doesn't feel like it should be working. Do you know what I mean?
Mm-hmm.
It just doesn't look right. But that was the Dymaxion car. There's the Dymaxion map, which you guys have heard of. You guys know the issue with the sort of Mercator protection that we use?
Yes.
Yeah? What is it?
Misrepresents the landmass sizes.
In what way?
Everything's out of proportion.
In that Europe looks significantly bigger than it is, and all the countries that are not white look significantly smaller than they are.
Have you seen that TikTok account where it's just people comment being like, can you put this country over this country? And it adjusts the sizes.
Oh, yeah.
And so you see, compared to each other, how big they actually are.
Yeah,
it's
because
very interesting.
Greenland looks massive.
Yes.
In the normal, so I say the Mercator projection. That's the map that we use. There's many different ways of. So the issue with making a map is that the world is not a flat rectangle.
What?
And, yeah. Well, trying to lay.
It's a flat circle. Okay, yeah, you're right.
So the world is spherical, more or less. Bulges a little bit in the center.
Okay, man.
Bulges a little bit.
I see you're on the payroll.
Look, please, there are actually people that have conspiracies about me being paid by the elites to spread.
How did they find out?
Look, stop it! Stop it!
We are the elites.
You're right. I know you're under an NDA.
No, honestly, I genuinely sometimes I worry about people that get that send me hate and stuff, and I genuinely find myself on Reddit the other day on a conspiracy Reddit.
Yeah.
Yeah.
Wow.
Yeah, I know, right? Made it to the big time.
You've made it.
So, the issue is that the world is a globe, right?
That is an issue.
No matter what those flat earthers say, the issue is that the world is a globe, and trying to take a rectangle and lie it on the flat on the surface of a sphere doesn't work.
Without bending it, yeah.
Without like you've got to warp it or bend it or make some cuts in some way.
Mm-hmm.
And if you don't want to make cuts, you've got to then warp it. And the way that our current map is warped is that the northern hemisphere is generally just larger than the southern hemisphere, which is weird because when you look at the actual size of Australia, it's big. It's real big. You look at the size of Greenland, a bit smaller than you think. The UK, tiny. Africa, huge. Absolutely massive continent. And just looks absolutely minuscule.
Yeah.
So what he did is he came up with this, which is the Dymaxion map, which shows everything without warping it in any way, which is pretty cool. Obviously,
it looks like looks like something you build at school when you're learning about like origami, and like when you like make a cube out of those 6 connected rectangles and then you fold them in.
Mm-hmm.
It looks like that. It looks like something you print out and cut out in like preschool.
Okay, class, we're going to be building our own globe today.
Remember, if you're listening on the audio version, this will all be linked in the description. But really what we're looking at is a map that is sort of cut out, and everything is the correct size. So on this, it's really cool. You can see that Africa, you can see the actual size of Africa in comparison to Europe, which is huge.
Wow, it's about the same size.
Yeah. Australia, for example, in comparison to the United States.
I was going to say, even if you look at Greenland there. Is that Greenland there? I thought,
that's Greenland, yeah. Yeah, Greenland is big, but on the current map we use, it's huge.
On the globe, Greenland looks bigger than Australia, but in reality, Australia's like 2 or 3 times the size.
On a map.
On a map.
On a map, yeah. Because the only truly accurate way to represent the planet is obviously on a globe, but globes don't lie flat usually. So the only issue with this, obviously, being that you can't really see north and south. Well, you can see north and south, but it's not as intuitive as would be on a traditional map.
But even then, north and south aren't real.
Yes,
like you could switch them if you wanted.
Yeah, but they're a useful concept. Is
Yeah.
My point is that we like to use you can see the lines of sort of latitude and longitude there, but it's not quite as, say, intuitive as it may be on another map. You know, but it is a really cool map. So that's kind of his philosophy of, again, you see, like, sort of getting the most out of it as little as possible.
It's really weird to see the South Pole represented as a landmass like Australia, because to us normally it's like this long strip at the bottom of the map.
Bottom of
Exactly,
the map,
yeah.
It looks humongous. Yeah.
I mean, it is still quite big.
Oh yeah.
It's huge still, but seeing all the little bits where it is and isn't is very interesting. So that's
It's not going to be there for long as well.
It's getting smaller, isn't it?
Visit it while you can.
Well, you could just chop that little bit of the map off.
That's true.
Don't even need to worry about it.
Oh,
yeah,
no.
save paper.
So there's also, this is something you guys might have heard of, is geodesic domes. You heard of these?
I've heard of it, but I don't know what it is.
No.
Oh, you know what a geodesic dome is. So a geodesic dome, I'll show one to you, then we can...
Is it the thing in the Simpsons movie?
It's not.
No.
Thing. That's the dome.
The dome.
Right. You might be thinking of something from The Simpsons, which is a song from Homer and Apu, wherein Apu sings about, how much he loves living with The Simpsons now. He says, whether igloo, hut, lean-to, or geodesic dome. That is the first line
You're
of
right.
that song.
That's exactly the thing I was thinking.
That's exactly the
Thank
thing you were
for
thinking of.
correcting me.
There you go. That's a geodesic dome.
A dome made out of triangles.
Yes. Yeah, it's actually, yeah. So do you know, what do you think might be sort of interesting about a geodesic dome in particular?
Is it the way that it distributes force? Because the triangles distribute the force nicely.
Yes.
Cool.
Yes, it is that. So a geodesic dome, so really, let's first understand what geodesic means. Something that's geodesic is it's a sort of spherical object that is made out of sort of like objects with straight lines. Like kind of like a football,
Right.
It's
right?
like
John?
the Eden Project would be a geodesic dome.
Is that the...
It's like these big plasticky domes. I think they might be plastic, made out of, I think, probably hexagons. It's a giant project out I think it's in Cornwall.
Oh, yes, actually, no, I remember. Yeah.
That's a giant greenhouse for like tropical plants.
Yeah. So yeah, that would probably be a geodesic dome. So the whole thing with geodesic domes is that they're spherical. They're sort of something that's spherical, but made out of shapes like a triangle or shapes with straight lines. So a football, for example, would be geodesic.
Yeah.
Because it's it's the pentagons
Right.
that make up a ball.
Yeah.
The
Right.
Pentagon makes all the balls. Is that where they all come from?
Yeah, a pentagon just poops them out, just drops them.
Wow.
You have
In
to
that
do it.
small building in
It's
America.
their side
I think
project.
all
The
the
Pentagon,
balls.
yeah, that's right.
I thought they were busy covering up the aliens.
So that's what a geodesic dome is. As I've said, it's sort of a dome that's made out of triangles. There's two types of triangles that it's made out of. One that's slightly sort of smaller than the other. If you're actually going to build one, you can build them out of sort of toilet paper tubes or kitchen roll tubes, or even just rolling up paper or anything. All you need is something to connect those pieces and a sort of like long, thin, so like a straw sort of shape, right? And then something to connect those. There's basically two types of triangles, like I said. One of the length of one of them is the length of the sides of one of them is about 80% of the other, and they're just sort of paneled together to make this dome. And what's really interesting about it is that it sort of distributes the force quite evenly. Look, as you said, so with a normal house, there are issues with distribution of force, for example, right? Like you've got to think about, and this comes when you're sort of engineering and you're in sort of architecture. You've got to think about, say, the force from the wind, or the force from snowfall, or the force just on the top of the house. So if there's a force on the top of the house, it's going to be distributed in some way through the house. And because our walls are generally tall and straight, it's sort of distributed directly downwards, which for skyscrapers and things like that, it means that there's a limit to the size that they can get to, right? Before they basically crumble under their own weight.
Can I ask a question? So
Yes.
you said that geodesic domes are made out of two different types of triangle.
Yes.
So then are things like footballs, which are not made out of triangles explicitly, they're made out of squares and I think maybe hexagons.
So-
Are they also ultimately they are triangles?
No, so they're geodesic. You could probably split them into triangles, but the point is that something that's geodesic is a sort of circular or is a spherical shape or a sort of hemisphere shape made out of sort of straight, like panels with straight lines. Do you know what I mean?
But you just said geodesic domes are made out of triangles.
So a geodesic dome, which was made by Buckminster Fuller, is something that is a specific type of geodesic object.
Right.
Which is made from triangles, panel triangles.
Oh, so something that is geodesic
Yes.
is a sphere made out of any other shape that has straight edges.
Essentially, yeah. It's made out of panel shapes with straight edges.
Okay.
Yeah?
Yes.
And a geodesic dome is the name for this structure that Buckminster Fuller invented.
And is always exclusively triangles.
I think, yes, it is traditionally triangles.
Okay.
I think you could probably stretch that and make them out of, I think I've seen some kind of hexagon, but I think ultimately you can then bring that down.
Subdivide those into triangles. Yeah.
Right.
So, I mean,
is it, maybe this is a bit pedantic, but is it actually a sphere or is it a sphere in appearance? Because it has so many sides. I mean, what is so many triangles? Exactly. Yeah, well, this is what I mean.
Yeah.
Has like, it's just a shape with like loads and loads of triangle sides.
Yeah.
But it looks like a spherical dome.
Yeah.
Okay.
So what you're asking is like, are the triangles curved or the triangles flat?
Or are they all straight? And there's so many of them to the point.
They look flat and then they're attached by slight angles so that so technically you're right, Jam. Yeah, it's actually a many sided shape.
Yeah.
But it is basically a sphere.
Because it's so big and there's so many triangles, it just looks.
Yeah, more or less. It's kind of it is curved but not quite. It's not quite a sphere, right? But then we get into the question of what is a sphere, because we say the Earth is spherical, but it's got imperfections on it. Obviously, if you were to shrink those imperfections down to, if you shrink the Earth down to the size of a golf ball, it would be sort of, or a billiard ball, it would be smoother than a billiard ball. But you know, still, it's not perfectly spherical. I mean, whenever we talk about any shape being spherical,
just in appearance, basically.
Well, yeah, I mean, like ultimately, it depends how closely you look, right?
Yeah.
How close are you to look? I don't know why I said that. Let's just chop that one out.
You don't look quite spherical.
Be fair, I am quite close to the Earth, looking quite close, and doesn't look spherical.
Doesn't look spherical, no. It looks quite flat, doesn't
Mountains are quite tall to me.
Well, if you think about it, what's the tallest mountain?
Everest.
What height is the tallest mountain, roughly, in meters?
Very tall.
That's 7,000. I've pulled that out my arse. I don't know.
You pulled 7,000 out your arse? Wow.
How tall is Mount Everest? Come on, Siri.
According to Wikipedia, it's 29,029 feet.
So about 10,000 meters.
10,000 meters? Yeah, and the deepest canyon isn't all that deep. So again, if you were to then like sort of, that's the difference that you've got around the sort of size of the Earth. If you're shrinking that down, that difference is tiny.
Yeah, like the dimple in a golf ball would be proportionally way bigger.
As a mountain?
Yeah,
that'd be huge. That'd
Yeah.
be giant.
Yeah.
Absolutely giant. Yeah. So Earth is pretty smooth. You know, just speaking sort of relatively. So yeah, a geodesic dome. The way that he sort of came up with this idea is through something he called energetic synergetic geometry. He loved coming up with names for things. In fact, he came up with names for things whenever he thought, oh yeah, the language that we're using, it doesn't quite fully describe what I want. So he came up with this kind of geometry that it comes from kind of the idea that essentially in nature there is a directionally orientated system of forces that provides maximum strength with minimum structures, right? So essentially the idea that you can get trying to look for the most strength out of as little material. So like a beehive, for example, right? It's a relatively strong material, a relatively strong structure that uses as little materials as possible. And in nature, that makes sense that you want to use as few materials because materials take resources to create and produce and lay out. But you want something to be as strong as possible. Yeah, look, you look confused.
No, I'm very happy.
You're very happy?
Yeah.
Good. Glad to hear.
That's good.
Good. Yeah, so you know that is he was kind of looking to nature and thinking, okay, well, how can we apply it to this? Because it's not only does it exist in say beehives, but there's also in organic compounds, like sort of carbon-based compounds. They've got sort of tetrahedral structures, wherein again the most strength is derived from as little material as possible. Yeah, and so that's the kind of system of geometry he created, kind of coming from that. And the basic unit of that system is a tetrahedron. Do you guys know what a tetrahedron is?
10-sided shape. No. Tetra? No. Oh, that's deca. Four-sided shape.
Yeah, four-sided shape. So it's a
really?
Yeah, it's a four-sided triangular pyramid. So the pyramid.
yeah, of course.
So it's one of those pyramids that whatever side you face down, it looks the same essentially, right?
Right.
So when most people think of a pyramid, they think of the pyramids in Egypt.
Square
right?
base.
That's a square base pyramid with 5 sides. This is a triangular base pyramid with 4 sides, and the sides are identical.
Triangle.
Yes.
Yeah.
And there's also if you add in octahedrons, which are 8-sided shapes, which is quite. It's almost like adding 2 of those together, but not quite because that's 6. It kind of look it up, right? It's hard to describe visually, but so tetrahedrons and then octahedrons. He basically thought, okay, these can form the most economic space filling structures, right? Where you can get the most sort of strength out of as little materials and as possible.
I am having vivid flashbacks to learning all this stuff in A-level physics.
Right?
Yeah.
Yeah. So
had a whole thing about Buckminster Fuller and all that stuff.
Really?
And it's just all coming back slowly.
Oh wow, that's awesome.
Wow.
Yeah.
So the logical conclusion of this was the geodesic dome, as we've spoken about, and this is basically a frame, really, right? You can obviously cover it in a tarp or fill it with whatever, but it's essentially a frame, and that's the idea of it. And because all of these flat sort of planes of sort of triangles are a kind of a skeleton to it. The way they're arranged, it means that the force is sort of distributed more evenly throughout the entire structure. In fact, I watched a video on it. It's about a 15-minute video. You can, it's linked in the description. It's pretty cool. It explains like, okay, if there's weight coming from the top, these are the forces that are applied to each of the things, and it kind of goes down in concentric circles so that it's applied evenly throughout the structure. Which means that the strength of a geodesic dome increases basically. In a logarithmic ratio to its size, which it kind of increases sort of faster than its size increases, which means that there's not really necessarily an upper limit to the size of geodesic dome that you can create, unlike with skyscrapers, where if you build them too tall, they're going to fall, right? Because the weight is not distributed evenly throughout the structure. Yeah?
So could we make a gigantic one that just covers the entire Earth and protects us from global warming?
Okay, Tony Stark.
Be nice.
Yeah. Wouldn't we have enough materials to do it?
If any, wait, how would it protect us from global warming?
Depends what you make it out of.
Well, wait, no, I want to hear.
Well, if you make it out of something
Ice.
that filters, if you make it out of something that filters out specific wavelengths of light, and then you put a bunch of some machines on it that suck out carbon and chuck it into space. I don't know. I'm not a scientist.
That's for them to figure out.
I'm just curious as to. I want to see what your.
Or you could do the opposite. You could use this as an idea of that sort of futurist idea of building a world around a sun. So you create a giant geodesic dome around a sun out of material, and then you have solar panels all on the inside, and you live on the outside of it, and then you have unlimited energy coming from the sun, and then you have plenty of gravity because you're around a sun, although probably too much gravity to be honest.
Well, it's a Dyson sphere you're talking about, right?
Yeah.
Yeah. So that you wouldn't necessarily live on the outside of it, but you would use the energy from it. Yeah. Cool. That's a cool idea. Very good. Look at you, next little Buckminster Fuller over here.
I'm going to start making up terms.
So the idea, what's interesting, the reason that I pressed you on the idea of protecting the Earth from global warming is that you can see geodesic domes used as sort of greenhouses, because you have the structure, and then you panel it with sort of the greenhouse material that traps in the sort of heat.
That's what the Eden Project is.
Yeah. Exactly. So it's interesting seeing the different applications of it. And again, it's just a really cool idea. I've seen concepts for houses built from geodesic domes, wherein again you can sort of build it. And the cool thing about geodesic dome is you can build it, and it's all one piece, and you can just drop it where you want.
Drop it down.
Just drop it.
Little house.
Yeah, you got a little house, and you can transport it wherever.
I assume you can build it out of lighter materials than the house as well.
Probably so. Yeah.
Because it's stronger per unit mass.
Yeah, and it does obviously depend on the materials that you build it out of. One built out of paper isn't going to be necessarily strong, but it's going to be one of the strongest. It's going to be the strongest structure that you can sort of build out of that paper. Think about it this way: like a house. If we want to simplify a house, it is really kind of a cube, usually with some kind of triangle on top, right?
Yeah.
With some sort of triangular prism on top, right? And it's
a pyramid.
or a pyramid.
Or a pyramid.
No, yeah, sure.
A pyramid on top.
Okay, sure. Okay. Yeah, we'll do that way. It's a cube.
Or a Toblerone.
Okay, right.
Oh.
That's a triangular prism.
Okay, we're going to get technical.
It's a really long house.
I think you'll find the everyman's triangular prism is a Toblerone.
Okay. So if you think about it, if you're making a structure out of paper, right? You make a traditional house. It feels like you could probably crush it very easily, but it'd probably take a bit more force to crush a geodesic dome, just because the way that the forces are distributed. Because you push down on the top, and it instead of sort of basically crumbling, the force is distributed right the way through the entire structure.
Socialist
Sure.
material
Socialist
structure.
triangle.
Well, it's actually really interesting because that's what I was getting from what I was reading about Buckminster Fuller. The way that he was describing the world, he said, there was actually a quote from him, which
because if you think about whilst you're finding that, if you think about like a roof, like say you put a lot of force on a roof, some of the force is going down into the rest of the structure, but a lot of the force is going to breaking the roof. But that isn't the case with these structures.
The roof would cave in.
And also, and another thing as well is that because they are much more streamlined, they get a lot less force from wind and air on the sides as well, right?
Yeah.
Which normal houses don't. So they're maybe slightly less disruptive, and also there are fewer forces that are going to be affecting them. Again, if there's heavy snowfall on the top of the structure, distributed all the way through, but also it's probably much easier for it to slide down the...
Yeah, but you do have quite a lot of the square footage wasted, because if you have a big circle that curves, then you've got all that space that you would normally have with a cube wasted around the edges.
Or you've got more... It depends on which way you think of it, right? You could have more space.
How?
Because you're thinking of the cube as being bigger than the sphere. Or you're thinking of...
I mean, in terms... I suppose because you can put them closer to each other as well. But like if for example you... Okay, yeah. So you can put them next to each other closer to each other than you could with square houses. You don't have to reserve a square plot of land for a circular structure. Is that what you mean?
Yeah. Well, yeah. I mean, you don't need. We think of sort of houses as being squares are really good for stacking and packing, right? They're really good for that. But we don't necessarily need to have houses be terraced in that way. If we're thinking about like houses made from geodesic domes, right? We don't necessarily need to have. We could maximize. We can have more space, essentially. Right?
Well, I mean,
in general, per person.
The square footage for a geodesic dome, you could have more internal space by building a cylinder there.
Oh yeah,
than
sure.
You could for a geodesic
absolutely.
dome.
Yeah, you absolutely could.
So you waste all that space outside of all the space you waste by having a curved structure upwards is a shame.
I mean,
yeah,
you could absolutely view it that way. Yeah, definitely. But I mean, there's different ways of view. There's a lot of space for a lot of people. Again, if you look at the actual stats of how many people there are on the planet and how much space we take up, we could all live on much smaller sort of surface area than you'd think.
Yeah,
right?
Just learn to cuddle.
Yeah. Obviously, there are issues with some areas being uninhabitable and deserts and farmland and forests and whatnot, but we don't need. There's much more space to go around than people often think, I would say. So the quote that I was talking about is he actually said, he said, "It's touch and go. If we stop wasting our money on armaments and use our high technology on living instead of weaponry, within 10 years we could have all humanity living at a higher standard than anybody has ever known. We could all be billionaires." It's lovely, isn't it?
Oh, that'd be nice, wouldn't it?
Nice, wouldn't it be?
We could all be billionaires if we just made our currency much weaker. Just that a billion wouldn't be a billion anymore.
Wouldn't mean anything, would it?
I think Bucky's idea I like that a little more.
Yeah?
I'm sorry. Look, I mean, you got to maybe work a little harder on that one before you're the next Bucky. So, Luke, we finally got to the bit that you're probably most excited about.
Balls.
Yes.
Oh.
Luke loves balls,
Sorry,
as we all know.
uncharacteristic.
Uncharacteristic.
Yeah, it's out of character for him.
Really?
Yeah.
Look, I've always known Luke to be a ball man.
Really?
Yeah,
I never got that from you.
Loves a little bit of ball. He never shuts up about the balls.
Balls.
Who are you? I feel like I don't know you.
So he patented the geodesic dome structure. And it came before this discovery in chemistry which was in the 1980s, of a carbon-60 molecule, a carbon molecule with 60 carbons. And the structure of it was really similar to the geodesic domes. And so in 1996, Harold Kroto, Richard Smalley, and Robert Curl won the Nobel Prize in Chemistry for basically sort of figuring out the structure of this carbon-60 molecule. And they named it Buckminster Fullerene in order of, to call back to his work. Yeah. So he didn't actually discover it himself, but it was named after him because it was similar to a structure that he had built as in terms of the geodesic dome. And there are other fullerenes. There are other fullerenes that have been discovered. Buckyballs, which are spheroid carbon molecules with fewer than 60 carbon atoms, and giant fullerenes, which have a few hundred carbon atoms. I think they can also be called, so they're also called Buckyballs as well.
Big daddy fullerenes, you call them.
And what is the benefit of Buckminster Fullerene? What are its properties? Is it 6 or 8 carbon atoms in a circle all joined together?
I honestly did not look it up.
Okay.
Yeah. I can look it up right now if you want.
Well, so pull a picture up of it. It's a really interesting, it basically is exactly the thing you were talking about with the geodesic dome. It's essentially like a geodesic dome, but it's not triangles. I think it's 6 organized in it. Yeah, there we go. 6 carbon atoms organized in a circle connected to lots of other carbon atoms organized in a circle.
Oh wow!
You used to get little magnetic. Yeah, you used to get little magnetic sticks that kind of join together in a similar way. I used to play with those as a kid.
I used to play with those in school.
Yeah.
Mm-hmm. No,
and
it's really cool.
It's a really strong structure, I believe.
Yeah,
and it's good at conducting electricity as well. I think
so. Yeah,
yeah,
probably would be. Yeah. Did you guys have chemistry where you used to play with the sort of the carbon? You pop them into you pop the bonds into the carbons and the oxygens and whatnot. Yeah, loved those.
I didn't do chemistry for that long.
I did chemistry A level.
Yeah,
good fun.
It's fun that we got to play with toys when we were in high school. I mean, it's nice that they give us that.
I played with something similar in primary school.
Well, I guess you're just way ahead of us then.
You were doing A-level chemistry in primary school?
Yeah.
So there's so many geodesic domes been made, and if you look around, you'll be able to find more. And now that you know what they are, I mean, if you didn't know what they were before, you'll probably start seeing a lot of them around because they're an economical structure to make. And sort of the last thing I want to talk about from Buckminster Fuller is the concept of Spaceship Earth. I'm sure you must have heard about that before.
Is it the idea that Earth is a spaceship?
Yeah. Kind of, yeah. Basically that.
What is a spaceship?
Where are we going?
Just around, really.
Cool.
We're going around the sun. Where's the sun going?
Going for
Around
a
the
wander.
galaxy. Where's the galaxy going?
Nowhere in particular.
Probably around a center of mass in a super galaxy cluster.
It's all relative.
Where's that
isn't it?
going?
It's not going anywhere.
Yeah.
Everything else is just going other places. We're staying still.
That's what I like about time travel movies, right? Because every single time travel movie has something in it that allows the time travel device to know exactly where the planet is at whatever time.
If you actually just transported back in time, say 10,000 years, and stayed in the same place in space, you'd just teleport into
Earth would be nowhere to be seen.
Empty space.
You would.
Where am I?
Because the sun is moving around, and the sun is moving around in the galaxy. Like it's baffling because you're like, okay, Earth is staying still, right? Because you're on Earth, you're like, Earth doesn't move, and then you're like, okay, let's zoom out a bit. Okay, Earth is moving around the sun, but the sun doesn't move. Then you zoom out a bit, and you're like, okay, the sun is moving around part of the galaxy, but the galaxy doesn't move. It's all moving all the time. But also it's not.
So any time travel machine would have to also be a teleportation machine that could correct for all those things if you wanted to go back in time or forward in time.
Yeah, have to know the movement of everything in the universe.
I feel like that would be harder than I feel like once you figured out time travel, that would be the hardest part. The teleportation thing.
Yeah.
Not just the teleportation, but the exact mathematics needed to figure out to pinpoint an exact point of the universe. Because everything's expanding and it's like that'd be tough.
Unless there's something we don't yet understand about the fabric of reality that means that that's not a problem, which there might be.
Yeah, maybe. Yeah, absolutely. You could definitely explain that away.
Fun fact, though, which I learned recently from an old episode of No Such Thing as a Fish, one of my favorite podcasts. We have basically gone one galactic year since the dinosaurs started. So we're roughly in the same place in the galaxy as when the dinosaurs first started being
that's
around.
fun.
That's cool.
So we've gone all the way around the Milky Way and ended up back roughly where the dinosaurs are.
Wow.
So,
But then obviously the Milky Way has moved. But
yeah.
within the Milky Way, yeah.
Wow.
Yeah, that's really cool.
Cool.
That's very cool.
Yeah.
Very nice.
So if you did time travel back to the dinosaurs, you'd be roughly correct.
That's
You'd
if the
be in-
well,
you'd
that,
be
Within a few light years.
You'd be in the ballpark. Yeah,
I mean,
a few light years away.
the
It's
Milky
fine.
Way is moving too.
Yeah.
Yeah,
So,
So,
yeah.
but you'd correct for that.
yeah, I mean, if you're
Sure.
correct for that, sure. I mean, how much can a galaxy really move?
I don't
you know?
A lot. At least a few kilometers.
I hate how big stuff is. I
I
don't like.
know.
I can't wrap my head
No.
around it. You know, because I'm thinking, oh yeah, I mean, walking to like central London. That's a bit of a walk. That's like 3-hour walk. It's a long way. Then I've
Yeah.
got to think, okay, well, walking to Scotland, that's a really long way. So walking to the sun must be like at least twice that. You know?
I find it really comforting to look at pictures of the Milky Way galaxy and be like, yeah, nothing matters. That's cool.
Yeah, it is nice to know that you could blow up the entire planet, and wouldn't matter all that much. It's fine.
Yeah.
You know, there's
I just
plenty
think of
more.
that. You know that pale blue dot picture where it's
Mm.
just us tiny, like 1 pixel big. Just see it go. Tiny little pop.
That's nice.
Yeah.
My entire life is just an infinitesimal speck. Good to know.
Some giant entity like pops planets like bubble wrap. And it's like pop, 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 pop.
Someone's falling asleep to this right now.
Yeah.
And has
Having
woken
an
up a
instant
little. Yeah,
progressive.
woken
Oh,
up to have an
no.
extent. Oh my god! Imagine if you fell asleep and then woke up with sleep paralysis and were hearing this.
If that's you, send us an email at sciguyspod@gmail.com.
So
When
long
your
as the sleep
paralysis is
paralysis
over.
demon doesn't get you.
Corey.
Make sure
What?
it doesn't type it for you.
That's not something you say to someone with sleep paralysis currently.
What are they going to do about it? They're paralyzed.
Write in. That's what they're going to do.
They're not.
But
They're
they're
paralyzed right
paralyzed,
now. They can't do
exactly.
nothing.
The demon will type in for them. They'll just say it. They'll be like, "Hey, type this," and the demon will go, "Okay."
Yeah, just use text to speech. I'm sure that'll work.
Oh, true. Yeah, I didn't even think about
Yeah. Hey, Siri.
Sorry,
that. Hey Siri, exactly.
why am I taunting some imaginary person with sleep paralysis right
Because
now?
you're cruel.
Yeah, I'm cruel. Okay, so Spaceship Earth. I've got a quote here for you. We have to rehouse humanity, he said. Space stations are the first serious housing project. We were born to be mobile. At this moment, we are spinning around Earth's axis at 800 miles per hour, while our little spaceship Earth zooms around the sun at 30,000 miles per hour. And our solar system rotates in its nebular merry-go-round at hundreds of thousands of miles per hour. When he talks like that, you can understand him. So the idea of Spaceship Earth, he, like I said, he made up phrases when language just didn't quite express exactly what he meant.
Real Chad move.
He's an absolute alpha.
Yeah, exactly.
So he made up the phrase Spaceship Earth because he felt that basically all people were passengers on Spaceship Earth, and we like if they were on a spaceship, everyone had to work together to make sure that the planet kept on functioning properly.
Yeah,
right?
That's nice.
Yeah, so you probably wouldn't have been too
What
hot
a
about.
commie.
Luke, you're a commie. Stop it. I do love when people hurl around commie as it's such an American insult to make. Like,
Oh,
oh, you
thanks for
absolute commie.
noticing.
And I'm like, all right, yeah, sure. Okay, that's fine. I'm not too upset.
No one's ever called me that before.
You know what? You're right. I do believe that people are equal and should get
that's
should get what they need. So,
So does the Declaration of Independence, by the way.
I mean, does it though?
Or is it the Constitution? One of those.
One of the Americans. I look. I know this. We recorded another one of these the other day where we didn't quite know what the American the difference between the Declaration of Independence and the Bill of Rights and the Constitution. And I know Americans are going to be in the comments being like, "How do you not? We don't care about your democracy. We don't know enough about it." But no, it does say what?
I don't frankly care.
Frankly, my dear, I don't
Yeah.
give a damn.
No.
I don't,
give a damn.
frankly, D. Roosevelt care.
Very good.
Thanks.
Yeah, no, what does it say? You said this. the
All
other
men
day.
are created equal. We hold these truths to be self-evident that all men are created equal.
Should have just
That
sung
sounds
Hamilton.
pretty commie to me.
Yeah. Well,
That is pretty common
it's pretty common.
for like
Well,
the
created.
king of
no,
capitalism.
hold on. Created equal does not mean.
Oh, so they
Yeah.
start equal but
Oh,
quickly
right.
become unequal.
Yeah.
After that, no.
It's equal opportunities, right?
Right.
But that only works.
But it doesn't happen.
Well, it doesn't happen, and also it ignores any sort of factor that is limiting equality, right? So you could say all men are created equal, but why are the blacks not succeeding? Well, probably because you did a slavery a few hundred years ago, and there's still issues lasting from that. You know,
haven't got all the capital.
No, they don't. They should have got the capital right at the start, right? They should have decided to get the capital way back at the beginning, and then they could make the.
That was where they went wrong.
That is it. They just didn't have the foresight to.
Exactly.
To get all the capital, all the resources, but
Or I don't know, commit a number of genocides. Should have done that as well, shouldn't they?
silly.
Jesus.
What do they have, a conscience or something?
Britain has done a lot of awful stuff, hasn't it? Like a lot.
Well,
dare you.
to put it lightly.
Yeah. So moving on. He, like I said, he felt that people were sort of like passengers on Earth. We needed to work together to make the world a better place. Everyone could live in harmony. Sort of we could all become billionaires if we stop being selfish and let like everyone live it. It's this idea that if we stop trying to compete and stop trying to basically win for ourselves and try and make everyone win, then the world could be a better place. I mean, we had this conversation. A few months ago.
We have this conversation quite a lot.
Yeah, I know,
Yeah.
but we had specifically the conversation a few months ago about the idea of a sort of zero-sum game, right? In a zero-sum game, if someone wins, someone has to lose. So if you gain one, someone ends up minusing one. That's a zero-sum game. You add them together, it adds up to zero. But where we are right now on the planet, in technology, all of the advancements we've made, it's not really a zero-sum game anymore, right? My benefit doesn't need to come at your detriment.
Yeah.
Necessarily.
Everyone can win.
Everyone can win. And if we work together to continue to sort of study and find new ways of making the world sort of easier to live on and a better place, then we could do that. His idea was that we could change the environment to suit ourselves, right? Which I don't know how much I agree with personally, but to an extent, it definitely makes sense, right? That instead of like you can alter the environment to be as suitable as possible, so we can use as little space and get as much out of the energy that we're putting in. And it's just a really great philosophy. So he hoped that someday all of the resources of the planet would be divided like sort of equitably, not equally. Bear in mind, because equality is not equity. Do you guys know the difference between those two?
Equal, everyone gets the same equities. Everyone gets what they need.
Yeah.
To put it basically.
Yeah, from each according to his ability, or to each according to his needs, from each according to his ability, that sort of thing. Yeah.
That also part of the American things? Is it not? What is it?
It's 2 marks.
Oh, is it the Communist Manifesto?
It's literally Marx.
Brilliant. Oopsie. I always get those two mixed up.
They're so similar, aren't they?
Oh my god.
Yeah.
So he, like I said, he traveled around the world doing speeches and giving lectures, and he wanted to convince people to try and basically address global problems like poverty and housing inequality and the terrible distribution of resources. And people called him a visionary because of that. Because bear in mind, this was at that point of the 20th century. I mean, right now we've still got people trying to convince other people to do that, and they're being called commies for it. Like
Exactly.
Yeah, commie. Sorry,
it's
Corey.
Corey. Yeah.
Easy to get the two mixed up.
You should have a second account, like a political account called Not Commie.
Commie Corey.
Not communist. I'm not. So I mean, that is sort of the story of Buckminster Fuller. I want to leave you with 2 quotes, one of which I've already read out, but I think it's worth reading again. Again, if we stop wasting our money on armaments and use our high technology on living instead of weaponry, within 10 years, we could have all humanity living at a higher standard than anybody has ever known. We could all be billionaires. And bear in mind, he died, in the 20th century, in 1983. So he said this before. He said this, from 1983 and before. Like, he said that back when we had that technology. 40 years ago, he was saying that within a decade, the world could, everyone could be billionaires. And he believed that then. Think about now, how far we've come now, to the point where most labor sort of manual labor does not need to be done by people. The only reason that we still have people in like working jobs in shops or working at difficult jobs in bars or dangerous jobs, all of these things, is because people need jobs to survive. Because we've set up a system wherein you need to work to survive. But we've also created the technology and the automation such that it doesn't make sense to do a bunch of these jobs that people need to do to survive. Because it could just be done automatically, right? So, and the issue, I think the issue is that because we're stuck in the mindset of, well, you need to work to survive, we're holding ourselves back so that we can play the little game of sending people off to crappy jobs so that we can keep the system running, you know?
What a game it is.
What a fun game. As long as you're winning, obviously. If you're losing, oh boy.
Oh,
Bad
dear.
game.
Very bad game.
That's like most games, though.
And I feel like some games are fun to play regardless of whether you win or lose.
That's
Yes.
true.
Yeah, this game is
Ideally,
awful.
Those are my
Yeah.
favorite games.
This game is not fun to play unless
No.
you're winning. It's like Mario Kart, you know?
Yeah.
Except
Still
Mario
fun.
Kart is equal distribution of resources. So equitable
Yeah.
distribution of resources.
True, yeah.
Yeah.
Wow. Commie game.
You're not getting a speed boost if you're first. I'll tell you that.
Well, you're not getting you're only getting a blue shell if you're
Blue shells, yeah, exactly.
yeah, you're not getting that bullet bill if you're in first place. You don't
Wait,
need
a
it.
blue shell is inherently Marxist.
Yeah.
Should be the red shell then, should it?
Wow.
Yeah. Think about that, yeah?
Did Mario Kart radicalize us as children?
Look, I think a lot of things radicalized us as children.
Mario Kart is Marxist propaganda.
It is.
It is.
And he said, I want one last quote to leave you with. The critical year is 1985. Within the next 2 or 3 years, we will know whether humans are going to stay on this planet or not. More will happen between now and 1985 than has happened in the whole history of the world up until now. And what do you think? Humans, we staying on the planet or are we not?
I think we're staying on the planet for the foreseeable future, so we better start looking after it.
As in, stay on the planet alive.
Oh, so you're
Yeah.
not dead?
Mm-hmm. Mm-hmm.
Well, I hope so.
Yeah.
I don't know.
Yeah.
I guess
Be
we'll find out.
optimistic, yeah.
Fingers crossed. I mean, this is the thing that this is the thing that I've been talking about for a little bit now. That I've been very doomer about climate change
Climate
every now and
change.
then. You know,
Me
it's
too.
been getting to me.
Yeah.
Yeah. You know.
Impending doom is quite scary.
Well, this is what I'm thinking. I don't think it's impending doom. I feel like it's an abstract concept, right? We're told, oh, we won't be able to survive. This and that will happen, but ultimately, I think that capitalism will just get worse. Like, I genuinely think that's what's going to happen because I don't think we can impact the planet such that every single person on the planet dies. We have enough technology to continue producing food to some degree, you know, regardless of the conditions. We have enough technology to survive fairly extreme temperatures. And ultimately, we can keep on surviving, just at a vastly reduced population. And the people that are going to, like, the population that is going to be reduced is inevitably going to be people in poverty and people that are, like, sort of working class, people that have less money, right? And that just means that the people that do survive with less money are just going to be further exploited by the people that have that sort of power and have that capital. And I feel like that's where it's going to go if climate change continues to, I guess, go unabated.
Yeah.
Yeah.
Damn.
Fun, right?
That is quite fun.
Yeah, so don't worry, you're not going to die off. You'll just become further slaves to the capitalist masters. But yeah, no, I mean, I think that Buckminster Fuller, his ideas were very interesting. I think that he had a lot to say, and I think we could sort of take a lot from his sort of his teachings, really.
The thing I wonder about is, so one of the things he says there is like, if we would stop spending so much money on defense. The thing I wonder about is that, like, for that to work, which obviously is a wonderful idea, every country needs to start doing it at the same time, because, or like theoretically, I guess, countries aren't going to start voluntarily disarming themselves when other countries aren't voluntarily disarming themselves. And if you're a country that have arms, and other countries are disarming themselves, then there's going to start becoming a political imperative or opportunity to invade countries that have started disarming themselves. And so how do you achieve that when you have a system that is not centrally run?
Everyone gets one nuke for every other country.
Sorry, what?
Every country in the world gets rid of all of their weapons, and they each get to have one nuclear weapon for every other country in the world.
So one nuke per country.
Yep.
So everyone.
So like 300 nukes, one for each recognized country.
Yep.
Everyone gets one.
How many countries?
Even the countries that are run undemocratically.
Yep.
So you're going to gift nukes to undemocratically run countries.
Yep.
That's a terrible idea.
And if they use them, then everyone else in the world uses them on them.
Fires theirs back. And then bye-bye that country.
That sounds like mutually, agreed destruction, which, was a terrible, terrible policy.
They will have a
in the
nuke
Cold
for
War.
every country. You can just...
If everyone has a nuke for every country, then everyone's equal.
How about we give a nuke to every country, but we don't tell all the countries that none of them work?
No, but then they'll have scientists that figure that out. Yeah.
And then that will cause a proper stink.
Yeah, but I just feel like it'd be very difficult to use a nuke knowing that everyone else is going to use it on you, This is not a serious proposition, by the way. I want to make that clear.
Back at you.
It's just one of those things where it's like absolutely a wonderful idea, but the really hard part is getting to that idea.
It's just...
And that doesn't mean we don't try. It's just like you can't like conceptualize of what if the world was entirely different from the way it is.
It's hard. It's hard, but I think
Sure.
the issue is, I think one of the main things stopping that is people saying, well, it wouldn't work. It wouldn't work. We can't do that.
Sure.
And the same goes for veganism. People, it's a slow process, but people are saying, well, it couldn't work. Planet couldn't be vegan. We couldn't reduce our impact.
But I just think that there are lots of people in the world who don't see world peace as the ideal. And I don't know what to do about that. Because some people really like fighting each other in competition. They get their kicks from that. And like a big... It's like that joke in the Simpsons movie where the lawyer is like talking... He like has a dream where like everyone's holding hands and it's singing in circles with rainbows and it's wonderful. And he's like... Ugh.
Yeah. Can you imagine a world without lawyers? Yeah.
I call it heaven.
That's great. But I mean, I think one aspect of that is people is gosh, it's like a game, isn't it? Like trying to shore up resources because we feel like if we have them all, then if someone else has them, then we're missing out.
Yeah.
It's just I do feel like a lot could be improved by shifting from a more capitalist world structure to a slightly more socialist one.
What about if we just did... So like there's this story, I can't remember which country it is, where like they all found out that they were just changing which side of the road they were driving on the same day. And so this country were like, okay, we're switching from one side of the road to the other side of the road on this day at this exact time. And there was not a single accident.
Because everyone
at that time, everyone stopped. They had a really complicated process of getting to the other side of the road, and then they just carried on driving. So what if we started educating everyone right now? Okay, right, we're doing this hey, new people in the world, we're doing this capitalism thing. It's been a bit crazy. Some people have really suffered the consequences of it. We're going to carry it on for now, but on this day, on this time, we're just going to change. And everyone is free to play the capitalism game for like the next 20, 30 years. But on this day, we're just going to change.
Yeah.
And you just tell everyone, and then we're like, okay, we see it coming. We'll enjoy capitalism whilst it lasts.
I've always thought of the idea in the back of my mind of like, how great would it be just to go and start a country? Like, there's a lot of division, right? There's a lot of political division. Why would it not be great to say take all the quite left wing people, go and start a country where you just run it the way that like, and it's just a very left wing country.
The US would invade you.
That's exactly the issue. I keep on thinking about it, and it doesn't work because America will invade. I don't know, maybe put a sign up next door to the next country over saying we have lots of oil here and next door doesn't, right? Maybe that'll stop them. Or you put up a sign in the window that's like, we're capitalists, don't come. Maybe they won't do that. Maybe they'll leave us alone then. But Jesus, no. There's no way of doing it. America would just invade. I think it'd be a really interesting experiment, but it would not work at all. So that is the episode, I think. But I've got one last thing to do with you guys.
Is it the quickfire quiz?
The quickfire quiz.
Yeah.
Hey!
Dun, 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 dun. Shapes edition.
So the quickfire quiz is very simple. I will ask you one question between the two of you. The first person to buzz in with the correct answer after I finished asking the questions wins. What do they win, champ?
Nothing.
Gosh darn right. Luke, what's your buzzer?
Balls.
Champ, what's your buzzer?
Squares.
How ironic. My question is, we've been talking about Buckminster Fuller, but what was his first name?
Squares.
Did you really just say balls?
No, I said squares.
You said butt square?
No, I said, squares.
Oh, well, I'll give it to Jep then.
Oh, Richard.
That
Because
is
Buckminster is short for Richard.
correct.
Well
Thank you.
done.
Well done.
Thank you.
Congratulations.
For some reason, I thought it was Robert.
Oh, no.
You would have lost the quick
You would have
fire
lost
quiz.
it, yeah.
I would have lost it, but I wouldn't have been losing anything, so that's perfectly fine.
Well, we wouldn't lose anything either.
See, just fun, healthy competition without, killing other people
Yeah.
or taking their oil. So, before we go, we'd like to thank all of our patrons with a very special thank you to executive producers Finn TZ and Ashley Muller. And also, thank you for watching. You can find the full references for this episode in the description. Subscribe for new episodes every Sunday, and why not leave us a nice wee comment? You can support the pod at patreon.com/SciGuys, or you can find and contact us at SciGuysPod on Twitter, Facebook, Instagram, and yeah, you can also find us at SciGuys on TikTok too. Or you can send us an email at sciguyspod@gmail.com.
SciGuysPod@gmail.com.
Sci Guys Pod.
At gmail.com, you can follow me at .core everywhere.
Follow me at Jumpkin everywhere.
You can follow me at Luke Cutforth everywhere.
Goodbye. Bye.
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 Oh.